Okay, so good morning, you guys. We just have a couple of quick warm-up slides looking at some factors. Okay, so we're starting with the factors of 3. And we are, of course, practicing those by counting up in threes. I want you to listen, read along with me, try our best to remember these. So we start with 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Next, we are going to do some factors of 4s, counting in 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Okay, last one here, we have factors of 5, and again, you guys are reading along or even talking out loud along. That would be fantastic. We have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Okay, so really quickly, just having a look at a new cognitive verb today. So cognitive verbs in maths are instructional verbs. Verbs, of course, being doing words, and they instruct or guide you as a student towards a specific type of answer. Okay, so they make it clear how the question should be answered and what sort of answer you should be giving. The new one that we're looking at today is, of course, expand, written here. And expand simply means that we are going to be removing the brackets. In mathematics, we use the word expand to show that we are removing brackets. Now, of course, as is usual, it's not as simple as simply rubbing the brackets out, but we are looking at the processes around expanding to remove the brackets from our problem in today's lesson. Okay, so before we get too carried away with our expansion, we are going to activate some prior knowledge in the form of this warm-up here. So what we're looking at really quickly is some of our index laws, some of our squared numbers, making sure that we have those facts rolling around in our minds somewhere. So this one here we might be pretty familiar with. We have 2 times 2. We've all done that a good number of times before, but we can rewrite it, of course, as 2 squared. So the 2 times 2, we have 2 multiplied by itself 2 times. So our base number is the number being multiplied, and then our power or our index is the number of times it's been multiplied. We have another example over here where we have x times x, and we can see that x is our base number because it is x being multiplied, and of course there are 2 x's being multiplied, so that is why we have the 2 up here. So there are 6 little questions here for you guys to have a go at. I highly recommend you pausing the video right now and you can have a go yourself. The answers are on the next slide when you're ready. Okay, answers. Tick them off, see how you went. Let's go through a couple very quickly. Y times y, so very similar to our example up here, except our base number or variable, I should say, is y. There's still 2 y's, so our power is 2. And as we said, our base was y, as y is being multiplied. C was a little bit different. We had this little coefficient out the front, that 3 hanging out there. So the 3 just comes along for the ride, okay? There's not too much tidying up that we needed to do for that one. Again, quite similar to our exemplar. D and E were kind of like trick questions because there wasn't any powers there. We didn't have any repeated variables, no repeated numbers, so we simply had x and y simplified by removing the times. Of course, when we don't see a symbol between those two, we know there is a multiplication occurring. E, very similar there. F, we had 3x times 2x, so we can tidy up our 3 times 2. Of course, we can write the 3 times 2 as the 6 and the x times x. So this again, we have a repeated variable. We have x times x, so there's 2 of them. So we get that power of 2. And then finally, we had 7 times 4. So we can do that times table. We can simplify that to 21. X times y. So we had 2 x's, x squared, and then a y on the end. Hopefully you can fix those up or tick them all and get ready for the next slide. Okay, so here we go, the distributive law. We have a definition that I would like you to copy down in your notebooks. The definition is written as follows. The distributive law states that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. Now, a little bit going on there, and what we're going to do is we are going to try and break that up a little bit. Now, that is an example of the distributive law in action. Okay, so what we're going to do is we're going to break it down really quickly and see where each of these numbers come from. So we have the 3 out the front. Now that 3 represents the number of rows. So we can see 1, 2, 3 rows, and the 2 and the 4, so the 2 is looking after these 2 blue squares in each of those 3 rows, whereas the number 4 is talking about these yellow boxes. Okay, so what the distributive law allows us to do is it allows us to separate away from looking at these rows into smaller bite-sized pieces. So the distributive law allows us to break a problem down into much simpler parts. And what we can see here is we had 3 times 2. Now if we have a look at the blue boxes separately, well, okay, we have 3 rows, and in each row there are 2 blue squares. That's where the 3 times 2 comes from. And of course, if we were looking at the total number of blocks, well, we would add that to the number of yellow squares. Now, of course, we still have 1, 2, 3 rows, okay? And in each of those 3 rows, there are 4 yellow blocks. This is, in essence, what the distributive law is allowing us to do. Move away from this entire row outlook and into the small bite-sized pieces of our blue and yellow squares individually. So what we're going to do is we're going to continue with both sides of the equal sign to double check that it doesn't matter which way we count up our squares, we get the exact same thing. So we're going to follow the BOMDAS on the left. So we're going to do our brackets first, and then what's outside of our brackets. Over here, we're going to do our multiplications first, and then our addition. So let's have a look. Okay, 2 plus 4 absolutely equals 6. Multiplying that by 3. 3 times 2 is 6. 3 times 4 is 12. Adding those together, and we get 18. So a really quick double check that our distributive law did work for this particular example, and it didn't matter if we had all together in our rows or if we broke it up on our right hand side. Okay, the takeaway though is this final point down the bottom here. Everything inside the brackets is multiplied by the number outside the brackets. I would like you to highlight that, put a little star next to it, make it stand out, because that is what we're going to do every single time. Fantastic. So let's have a look at some examples. So these ones here are the I do. So we're going to be watching along, seeing how I set out the problems, and if you'd like, it's probably not a bad idea to copy them into your workbooks as we go. So 5 times 4 plus 7 with our brackets in there. Now that key part at the end where we circled, highlighted, made it stand out was that we're going to multiply the number out the front by every value inside the brackets there. Okay, so we're going to do our 5 times 4, okay, and then we're going to add that to 5 times 7. Okay, then it's just a matter of following our BOMDAS. Nothing too tricky yet. Okay, so we have 5 times 4, which equals 20. Add that to 5 times 7, which is 35, all equal to 55. Oh, there we go. So again, if we just have a little recap of what we've done there. We started with our 5 out the front, and we're going to multiply that 5 by every single number inside our brackets. So it's like saying we have 5 rows where in each of those rows there's 4 blue squares and 7 yellow squares. And we're trying to count up how many squares there are in total. So we had 5 times 4 lots of blue squares, 5 lots of 4, and then 5 lots of 7 yellow squares. Figuring out the blue, figuring out the yellow, adding them all up. Okay? Nothing super tricky. Now, if we have a look at B, we might notice that there is a subtraction in there, which is going to change things up just a tiny little bit. So let's have a look at how that goes. Well, we'll follow our golden rule from before, which says that we have 4 times 8 and then 4 times 3. Now, that's all well and good. So let's start out 4 times 8. Now, as we said, that subtraction is a little bit different. Not too different though, because all we're going to do is instead of having a plus in between our two multiplications, we are simply going to take the second one away. So 4 times 3. That's the only difference. There's a subtract. Well, it makes sense that we're going to subtract. So let's work this problem out. 4 times 8 is 32. Take away 4 times 3, which is 12. Okay, final step, 32 take 12, 20. Happy days. Next up, guys, we have a we do. Now, your job is to fill in the blanks in the following 3 problems. Now, fortunately for you, there is some working out already done. All that you'll have to do, as I said, fill in some of these blanks here. Having trouble, remember the golden rule, which is to multiply the number at the front by all the numbers inside the brackets. You guys are going to have 2 minutes, as it says down the bottom. If you guys can pause the video, have a go yourself. We'll come back together and do the answers in a second. Okay? As I said, pause now. I'll see you in a few minutes. Okay, so hopefully you guys have unpaused the video now and we're ready to go through the answers. So we have 4a, we have 5 times bracket, 2 plus 4 close bracket. So the number that we are going to multiply by is, of course, the number out the front, 5. So it's 5 times 2, and then 5 times the other number, which is 4. Now, you guys might like to add in some extra working in case you need it, and evaluate those 2 multiplications. So you might like to evaluate 5 times 2, which of course is 10, and the second one, 5 times 4, which should be 20. There we go. Last step is to add those together. 10 plus 20, you get 30. There we go. So moving on to B, and it is very much a similar thing. Different numbers this time, of course. We have a 3 at the front. We're going to multiply that by the numbers inside our brackets, which are 2 and then 6. We're going to add them together as well. So go ahead, fill in our blanks. We said the number out the front is 3. The number out the front is what we multiply all of our numbers inside by. So we have 3 times 2, and then of course 3 times 6. I'm going to check those numbers off there. 3 times 2 is 6, 3 times 6 is 18. Adding them together for your last step, which is 24. C is slightly different, and hopefully you guys picked up on that as you were having a go. You might see that again we have one of those cheeky little subtraction symbols. So we're going to keep an eye on that one. But we'll proceed as normal for now and deal with that when it pops up. So we have 2 is at the front, and it is going to multiply by all the numbers inside. So we're going to have 2 times 9 is already written in for us. And then we have that subtract there so we don't forget it. 2 times 3. So we have 2 times 9 is 18. And then we have minus 2 times 3 is 6. So basically it is 18 plus negative 6, which is the same as subtract 6. Now, either way, if you like to put your subtract in there, fantastic. If you like to have your subtract in place of that addition there, like we were doing in the previous slide, that works too. Completely up to you. Both ways work really, really well. Okay? Great. So on to everyone's favorite, which is the you do. Maybe that's just my favorite. You guys are going to have, again, another 2 minutes. And if you can have a crack at those 3 problems on the slide there, you're going to answer those in your books. So one last time, number out the front multiplied by the number inside the brackets. When you're ready, you can pause this video, 2 minutes to have a go at it yourself. We'll come back together, do the answers. See you in 2 minutes. Okay, welcome back. Let's get straight into it. So we have the number at the front, which is 9, and it is going to multiply by the 2 numbers inside. Now the first number was 3, and then there's a plus, and then the number out the front times by the second number, which is 8. Okay, I'm going to do a little bit of in-between work. I'm going to hopefully remember my 9 times tables. 9 times 3, 27, plus 9 times 8, 73. And we're going to add those 2 together, which should be 100. Okay, same process over and over again. Let's try blue. Change the color up a little bit. Number out the front multiplied by the 2 numbers inside our brackets. Let's do it. 2 times first number is 5. Then we have that cheeky subtract in there again. 2 times 4. Let's evaluate some of those multiplications. Make sure we're following BOMDAS. So we have 2 times 5 is 10. Take 2 times 4 is 8. 10 take 8. Should be equal to 2. Last one. Number out the front multiplied by the 2 numbers inside. So we have 3 times first number is 6. We have a subtract, so we'll put that in there. Number out the front times the other number in our brackets. 3 times 8, getting a bit carried away. 3 times 6 is 18. Take away 3 times 3, which is 9. Doing that subtraction leaves us with a 9 as our answer. Hopefully your answers look something like that. If they don't, have a look at how you maybe missed a step or did your multiplication wrong and fix them up so your notes are perfect. Okay, the distributive law. Okay, so the distributive law can be applied to algebraic variables. So far, we've only seen it used for numbers, okay? And we've been able to evaluate them. We've been able to carry out our multiplications and additions, or sometimes the subtractions. So what happens when we start putting in our x's, our y's, our z's, our favorite letters? Well, turns out it works exactly the same. We have our number 3, and it is going to multiply by every number inside of our brackets. So we end up with 3 times x, and we're going to add. Where's my pen gone? Somewhere. Okay, 3 times 4. Fantastic. Tidy that up. Well, the difference here is we can't really do too much more to 3 times x than simplifying it as 3x. Of course, we can still evaluate 3 times 4, it's still 12. It's exactly the same. Okay, there's a couple of examples down the bottom there if they take your fancy, but definitely make sure that the definition is in your notes. Okay, and this example is also. Okay, so I'm going to have a look at another couple of I do's, so following along, watching these examples and getting them in your notes. So the color coding is really helpful with these ones. It can help us keep an eye on our variables and our numbers out the front. So we have our 2, our red 2 out the front there, our blue x, which is our variable, which is our new sort of component in this particular problem, and then our 3 at the end. So if we have a look, following our distributive law, it's exactly the same. 2 times x plus 2 times 3. We can simplify where we can. 2 times x isn't going to get too much nicer than that one there, so we'll leave it. But of course, 2 times 3 can be evaluated to 6. 3 bracket x take 5. Again, multiplying the number out the front by every number inside the brackets. So we get 3 times x. Of course, we had a takeaway, so we're going to keep a takeaway. Take away 3 times 5. Happy days. Okay, so what we have here, guys, is another we do, this time still with our variables added into the problem. So like before, what I need you to do is I need you to have a go at these yourself. I'll give you guys 3 minutes to have a go, and then the answers, we can go through them after that time. So as I said, you ready? Pause the video and I'll see you soon. Okay, hopefully you are back and ready to go through the answers with your own attempts written in your books. So, like before, all we're doing, that first number is going to multiply those two numbers inside the brackets. So the number out the front is 4, and it is going to multiply by both. First one being y, we have a plus, so we're going to keep a plus, and then we have 4 times 3. Tidy that up. Well, we can't do too much to the 4 times y. We'll just write it as 4y plus 4 times 3, which is 12. Great. Hopefully that looks familiar. Next one, we have 3, and it is going to multiply the two numbers inside. 3 times, oh, that is another 3. Let's try that one more time. Should be a 3 times x plus 3 times 7. Okay, simplify, tidy that up, we get 3x plus 3 times 7 is 21. Last one, 5 times everything inside of our brackets. So first thing in our brackets is the y, so we get 5 times y. This time we have our first subtraction in this lot, so we're going to subtract 5 times the other number inside of our brackets, which was a 2. Tidy that up, 5y take 10. Hopefully they all look pretty good to you. Okay, so now is your chance to have a go by your lonesome and apply those skills that we have been practicing. So if you need a little reminder, you definitely still have your little rule up the top to help you out if you need it. These 3 problems here are the we do. So we'll give you guys 3 minutes to have a go at that. Pause the video, come back, and we'll check the answers in a second. And our answers. Welcome back. Have a look, tick them off. Hopefully they all look pretty familiar. Okay, so what we're going to do, guys, we are going to step things up just a little bit more and have a crack at these new problems. As you guys have a look, you might notice this additional little number out the front here in front of each of our coefficients, in front of our variables. Okay, we're going to see how to expand this. Now the process is exactly the same, just a little bit more tidying up to do. So let's see how we go. These are our I do, so as usual, you guys are watching along, maybe taking some notes at the end here. We're going to multiply the number out the front by every single number inside the brackets. So let's just go ahead and see what that looks like. So we have the 2 at the front times the next term, or the first term I should say, which is 3x. So then a plus. We have the number out the front times by the number inside. Now, if we have a look at this, it's very, very similar to our previous problem, except we can tidy up this first term here a little bit. Because if we had 2 times 3x, or 2 lots of 3x's, we would actually have 2 times 3. We would have 6 x's in total. 2 times 2 is 4 as usual. So a little bit different
tidying up that first term with our variable in it, but that's all there is to it. Next one, 4 times 2x plus 4 times 5. Let's have a look. 4 times 2x plus 4 times 5. Perfect. Let's tidy it up a little bit. So again, 4 times 2x, we can tidy this up, and it becomes 8x. 4 times 5, 20. Happy days. Last one, 3 at the front, times the 2x, times the 7. 3 times 2x plus 3 times 7, 6x plus 21. How good? Okay, hopefully we're all good with those steps because it's your turn on the next slide. Rightio guys, here we go. A couple of you-dos. So, I'm going to give you 3 minutes here to have a go at these problems yourself. Okay, again, we have the little rule book up the front here, which reminds us on how to apply our distributive rule, but you guys, like you have been this entire lesson, 5 times the numbers inside here. Pausing for 3 minutes, your turn, see how you go. And welcome back, our answers are on the board here, and hopefully they look pretty familiar to you. If they're not, no worries, maybe fix them up, have a think about where you went wrong. Okay, and again, we're going to have a crack at that next step. Let's try some trickier problems. Now we can keep getting trickier and trickier because our rule is still the same. We follow these steps again and again and again. The step is we multiply the term or the number at the front by everything inside. Okay, let's have a go at this first one. So the term at the front is 2y multiplied by what's inside the bracket. So inside the brackets is 3c, and then we're going to take away 2y times 4y. Okay, so 2y, term out the front, multiplied by 3c, take away 2y, 4c. Let's finish that off. So what we're going to do is we're going to look out for opportunities to simplify our problem. Okay, so we can tidy up 2 times 3. 2 times 3 is 6. But if we think back to our warm-up at the very start of this PowerPoint where we were looking at squares and index laws, well, there's not too much to tidy up with y times c. Okay, they're two different variables, and so we will have to leave them like that. We have a takeaway, so we'll keep that there. And of course, we can tidy up our numbers. 2 times 4 is 8. Okay, but this time we have a y, and they are multiplying each other. So we have the same base, we have y multiplied 2 times, so we can write it as our y squared. Again, if you're not quite sure, have a quick look at our warm-up. Hopefully that clears up your misunderstanding there. Part B, so we have 3b, and it's going to times by the two numbers inside of our brackets. Let's have a look. 3b times 2a, take away 3b times 5b. Let's fix up that times there. Again, okay, when I'm doing these problems, I'm not even looking at what I'm multiplying yet. Okay, I'm just writing down the rule. The first thing times this first thing in the brackets. The first thing out the front times the second thing in the brackets. It's the same thing over and over. Now I'm ready to start looking at what those things actually are, and I can simplify from there. So I have some numbers. Tidy those up because I have 3 times 2, which is 6. I have a b and an a, so they're two different variables, so I might just write them in like that. I still have a subtract, so that'll stick around. Times the numbers together, 3 times 5 is 15, and this time I have a b and I have a b. So similar to our first problem up here, where we had y and a y, we wrote that as y squared. So this time we have a b, it's times by another b, so I have b multiplied itself 2 times b squared. Last one here, 2a times everything inside the brackets. That doesn't change. 2a times the first thing in the brackets, which is 3a, and then I have a plus, so I have a plus 2a because it's outside the brackets, times by 2b inside the brackets, and tidying it up, 6a squared plus 4ab. Hopefully that looks good to you guys. And now it is your turn to have a crack at some of these problems. So, like before, 3 minutes, set your timers, have a pause in a second, and I'll see you in a few minutes. Good luck. Okay, and answers are up. Tick them off, or maybe you didn't quite get a couple of those right. That's fine, we're still learning, and these were the trickiest ones we saw today. But make sure you fix them up, please. Get them in your notebooks. Make sure that they are well written, very legible, nice and tidy.